Good evening, everybody. My name is Ferhan Mazher, and the subject today we are studying in this episode is um, Pure Maths 1. We are doing the solution of the course book of the Pure Maths of 1. This is syllabus content of the paper 1 of the Cambridge International ASA Levels Mathematics 9709. From the course book of the Pure Maths 1, we are working on the exercise 8E. This is our second episode on this exercise. The topic of the exercise is practical application of connected rates of change. The chapter is about further differentiation. So in my first episode, we have already done from question number 1, 2, and 3. In this episode, we are starting the work from the question number 4. So let me show you the question. So on your screen, the question number 4 is showing up. So I'm going to attempt the question number 4. You can take the photo of this. Okay. He says that a square has side length x centimeter and an area of the a centimeter square. Okay. So we are basically talking about a square and each side is x and its area is a. Okay. Centimeter square. Okay. So this is given. He says the area is increasing at a constant rate of 0.03 centimeter square per second. Okay, the area is increasing. dA by the dt is equals to 0.03 centimeter square per second. This is given in the question. Okay, the area is increasing at a rate of 0.03 centimeter square per second. Find the rate of increase of the x. So we have to find out dx by dt. This is the question. When a is equals to 25. This is the question. Okay. So let me, the area of the square. The area of the square is equals to the L square, means length multiply length. So we can write the formula. The area is equals to length multiply length. So area will be equals to x into x. So the area will be equals to the x square. This is the formula which relates the area and the side x of a square. Okay, now I will derivate it. So derivate both the sides. So you will have dA by the dx equals to 2x. Okay. Now, when a is 25, first of all, let me find the value of when the a. What will be the value of the x? A is x square, so the x will be equals to 5. I'm not taking the negative value because the x is side. It must be positive. So dA by the dx, when the x is equals to 5, will be equals to 10. Okay? So now I will apply the chain rule because I want to find out the value of the dx by dt. Okay? So I want to find out the value of the dx by the dt. So that will be equals to dx by dA into dA by the dt. Okay. So basically dA will be cancelled. It will become dx by dt. So I have applied the chain rule. Now We will put the values. This is dx by dt equals to dx by dA. This is dA by dx. So dx by dA will be 1 by 2x. Okay. And dA by dt, its value, sorry, I know this value. Dx by dA, we have this in numbers, we have this value. But dx by, it will be 1 by 10. Multiply dA by dt, how much is that? 0.03. So this is 0.03 divided by the 10. So the dx by the dt will be 0.003 centimeter per second. So this will be the rate of the change in the x. Let me check the answer, sir. 0.003 centimeter per second. So my answer is right. Okay. So we use the chain rule and we found the value of the dx by dt. So this is how you will do the question number 4. I hope you understand. So my dear students, now we are going to work on the question number 5. So let me first of all show you the question. The question number 5. He says a cube has a side of length x and volume v centimeter cube. The volume is increasing at a rate of 1.5 centimeter cube per second. Find the rate of increase of the x when the v is equals to 8. Okay. Now, basically, we are talking about a cube. Cube, the length and the width and the height is same. So, you know the volume of the cube is how much? The volume of the cube is L cube. Okay. The length, width and height. Okay. Now, the things which are given to me is that the volume is increasing at a rate of the dV by the dt is given. That is 1.5 centimeter cube per second. And then his question is find the rate of the increase of the x. The dx by the dt is the question. And when the v is equals to 8. Okay. So we are talking in centimeters. Okay, centimeter cube. Now, very simple. First of all, let me make the formula. You know the v is equals to the length cube. Okay, the volume is given by the L raised to power 3, which means the side is x, okay, cube. The volume is equals to the x cube. Okay. Now I will differentiate both the sides with respect to the x. So it will become dv by the dx equals to 3x square. Okay. So I differentiated it. And you know, he said when the volume is 8. So when the volume is equals to 8, so that means x cube is equals to 8. So I will take the cube root on both the sides. So take the cube root on both the sides. So the x will be equals to 2 centimeter. Okay. So this x value I will take. Now they have given me, I know that dv by dx. So dv by the dx when x is equals to 2. I have taken x equals 2. So I know the dv by dx, the formula I just calculated is 3x square. So when the x is equals to 2, it will become 3 into 2 square. 4 3s are 12. So dv by the dx, its value will be 12. Now I will apply the, because I want to find out the value of the dx by the dt. So I will apply the chain rule. The chain rule says that I want to find out dx by dt. So dx by the dt will be equals to dx by dv into dv by the dt. So this is my chain rule. Basically, you see what will happen. The dv and the dv will be cancelled and you will get dx by dt. Now I know the value of the, I know the value of the dv by dx, that's 12. But here I have dx by dv. So I will write 1 by 12. So this is 1 by 12 into dv by dt. They have given us, that's 1.5. So you can use your calculator and find the value. So it will be 1.5 divided by the 12 and it will be 0.125 0.125 centimeter per second. So my dx by the dt will be equals to 0.125 centimeter per second. Let me check if the answer is right. So we have done the exercise 80. It's question number 5 in the book. The answer is 0.125 centimeter per second. So our answers are right, sir. You can see the question that is in front of you. The dv by dt was given, and when the v was 8, the question was what is the dx by dt. So very simple and straightforward question. I hope you understand this. My name is Ferhan Mazher and I am from Sargodha, Pakistan. So let's go to the next question. So my dear students, we are going to attempt the question number 6, and on your screen the question number 6 is showing up. He says a solid metal cuboid has a dimensions x by 4x centimeter. The cuboid is heated and the volume increases at a rate of 0.15 centimeter cube per second. Find the rate of increase of the x when x is equals to 2. This is the question number 6. Now, I know that this is a cuboid. Okay, so you see I have tried to draw a cuboid, and the dv by dt, the rate of change of the volume is given, that is 0.15 centimeter cube per second. Their question is find the rate of increase of the x when the x is equals to 2. Very simple, straightforward question. You know the cuboid, its volume is length multiply width multiply height. So you multiply the 3 dimensions. So we know that the volume is equals to the length multiply the width multiply the height. So volume will be equals to x into the 4x. So the volume will be equals to 4x cube. So this is the formula which relates this is the formula for the volume of this cuboid. So it will be 4x cube. And now I will derivate this. Okay, I will derivate both the sides. So it will be dv by the dx equals to 4 into 3 into x raised to power 2. So it will be dv by the dx equals to 12x square. So this is how you will derivate it. Now they have given me the value of the x, so I will find the dv by dx value when the x is equals to 2. So I can say when x is equals to 2, the dv by the dx, that will be equals to 12 into 2 and its square. So that is 12 into the 4 and that is 48. Now I know the value of the dv by the dx. When the x is equals to 2, the value of the dv by dx is equals to 48. Okay. Now I will apply the chain rule. The chain rule says that if you want to find out dx by the dt, so that will be equals to the dx by the dv into the dv by the dt. So I have applied the chain rule. Okay, I want to find out the dx by the dt and the dx by the dv into the dv by dt. So basically what happens, these two will be cancelled. So dx by dt, I know the value of the dx by dv. I know here the value of the dv by the dx, but this is dx by dv. So you will reciprocate it. So it will be 1 by 48 and the dv by dt is value is given, that is 0.15. Okay, so we will just calculate. Just enter these values in your calculator and you will get the answer, sir. 0.15 divided by the 48, and that is my calculator is giving, okay, so this is 0. Wait, 123,125. This will be centimeter per second. Oh, sorry. The answer they gave is 1 by 320. So let me see, 1 divided by 320. Yeah. So our answer is right. They gave the answer 1 by 320. When you divide 1 by 320, you get the same answer, sir. So this is the rate of the change of the. In the book, they have given this as this. This and this is the same answer, okay? When you can check on your calculator. So in this episode, number 2, on the exercise 8E, we have done question number 4, question number 5, and question number 6. My name is Ferhan Mazher, and we are working on the solution of the course book of the Pure Maths 1. The purpose of this video is to provide help for those students who has adopted for mathematics in their AS and their basic mathematical skills are weak. So they need this guidance, step-by-step guidance from a teacher. So we will provide this guidance and through our YouTube channel. So if you find this video useful, if you find this video interesting, if you think that this video is helpful and it can be helpful to other students as well, please share the link of this video with them, like this video, subscribe my channel, share the link of this video on in your WhatsApp groups, in your Facebook, on your TikTok, on your Instagram. You see, when you share the link of my video, it's appreciation for my work. It is support to my work. Your appreciation and your support is very, very important for me. So thank you very much, everyone. Have a good night. God bless you all.